Hi and welcome. In this video, I'll be discussing Module Excel Set A Question 2 from the chapter Atomic Structures. Let's look into the question. Given the following sets of quantum numbers for the 3 electrons at the highest energy orbitals of element X, what is given to us is all 4 quantum numbers for these 3 electrons, which would be the principal quantum number, angular momentum quantum number, magnetic quantum number, and electron spin quantum number. Now let's look into question A. State the type of orbital accommodated by the above electron. In order to know the type of orbital, we should focus on the angular momentum quantum number, which indicates the type of orbital. So L value equals to 0 would be the s orbital and L value equals to 1 would be the p orbital. Thus, the type of orbital present for this set of quantum numbers would be the 4s and also the 4p orbitals. So the next question is, write the electronic configuration for element X. Since 3 electrons at the highest energy level orbitals of element X are given to us, it means these 3 electrons are the valence electron. And as you can see, from the first set of quantum number and the second set of quantum number, the 4s orbital is fully filled with electron, as it has a positive half and also electron spin quantum number of negative half. So the valence electronic configuration for element X would be 4s2 and 4p1. This is so because at 4p orbital we only have one spin up electron. Since this is the valence electronic configuration, it means that all the inner orbitals are fully filled with electron. According to Aufbau principle, we should start filling our electrons from the 1s orbital. That would give us 1s2, 2s2, 2p6, 3s2, 3p6, yes, 4s2 first. And since 4s2 is now filled with electrons, it goes to a higher energy level. Therefore, we would have completely filled 3d orbital, which is 3d10, followed by 4s2 and 4p1. Right. Now the next question is to determine the atomic number for element X. Atomic number is the proton number for element X, and since element X is neutral, it means that the total number of electrons equals to the total number of protons. So all you have to do is add the number of electrons present, which is equivalent to 31, and that is your atomic number. For question D, you are required to predict the stable oxidation number of element X and write the electron configuration of it. Now, in order to form a stable ion, you should remove its valence electron. Therefore, element X has 3 valence electrons. So by removing these 3 electrons, we would get an ion X3+. with an electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10. Now, don't forget to answer the stable oxidation number, which would be positive 3. Remember, oxidation numbers are written with sign first, followed by number. Now, for the last question in question 2, you are required to find the number of electrons in element X with the corresponding quantum number. In order to do this, we need the electronic configuration. So I'm going to rewrite it back here. Okay, I'm going to rewrite it such that the 3d10 comes first. Now, for the first part, L value equals to 1. L value equals to 1 indicates that it is the p orbital. So all we have to do is focus on all the p orbitals present and total up the electrons. So what do we have is 2p orbital, 3p orbital and a 4p orbital. So the total number of electrons from the p orbitals would be 6 plus 6 plus 1. That would give us 13 electrons. Now for the second question, it requires you to find the number of electrons when the magnetic quantum number equals to -1. First of all, ask yourself, how do we get this magnetic quantum number -1? We would actually get it when L value equals to 1 and when L value equals to 2, because we know that L value determines M value, and M value would take a value that is from -L to 0 to positive L. Thus, when L value equals to 1, M value would be -1, 0, positive 1, and when L value equals to 2, it would be from -2, -1, 0, positive 1, and also positive 2. So both these L values will give an M value of -1. Alright, so now let's look into the orbitals that correspond to L value 1 and L value 2. That would be our p orbital and d orbital. So again, we have to focus on 2p orbital, 3p orbital, 4p orbital, as well as the 3d orbital. In order to understand this question better, I'm going to draw out the orbital diagrams for the selected orbitals. So let's begin with 2p, which has got 3 platforms. Then we have got our 3p, which also has got 3 platforms. And we have our 3d, which has 5 platforms. And our 4p, which has got 3 platforms. Now let's start filling up the electrons. 2p is a completely filled orbital, therefore we have got 6 electrons in it. Same goes to our 3p and our 3d. As for 4p, we only have 1 electron filled. Now, as you can recall from our class, I did ask you to label the M values for each platform, although the M values are not fixed for each platform, but this would help us to understand and answer the question better. Therefore, when L value equals to 1, for the p orbital, the M value should take up -1, 0, and +1. Same goes here. And for D, we would start writing it from -2, -1, 0, +1, and +2. And for the p orbital, again, it would be -1, 0, and +1. Thus, now all you have to focus is calculating the number of electrons that is in M -1 value. So that would be 2 plus 2 plus another 2 and plus 1. So answer for question E2 would be 7 electrons. And since I did mention in class, M value is not fixed for a certain platform, so answer of 6 electrons is also accepted. Because at 4p, maybe the first platform can be 0 M value or +1 M value. So for this question, we have 2 answers that can be accepted. Now let's look at the third question. It says here, find the number of electrons when L equals to 2 and M equals to +1. So again, please recall that L equals to 2 refers to the d orbital, and we are lucky that in this question we only have one 3d orbital. So let's focus on that. Let's open up our 3d orbital. So 3d has got 5 platforms, and our 3d is completely filled with electrons. So let me change that to red color. Okay. Right. Next up, what we are going to do is that we are going to give M values for our 3D orbitals beginning from -2, -1, 0, +1, and +2. Thus, how many electrons are there when L value equals to 2 and M value equals to 1 would be just 2 electrons, as we only have one 3D orbital and one of the platforms in it correspond to M value +1 with 2 completely filled electrons. So answer for number 3 would be 2 electrons. And finally, for question number 4, how many electrons do we have which contains electron spin quantum number -12? Although some of you might be able to picture this clearly without even drawing the orbital diagram, I'm going to draw the orbital diagram so that you can see clearly what you need to calculate. So let's draw the orbital diagram for the full electronic configuration, beginning with 1s, 2s, 2p, 3s, 3p, 3d, 4s, and 4p. I'll just put it at the side here. Okay, so label them 1s, 2s, 2p, 3s, 3p, 3d, 4s, and a 4p. Right? So I'm going to fill them up with electrons. So these are all fully filled. Alright, so now spin -12 indicates the electron pointing downwards. So how many do we have? Basically, we have got one on each platform over here. So let's quickly count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is basically half from the atomic number -1 of it, because 4p would be electron spin upwards because there's only one electron. So the answer for number 4 would be 15 electrons. Alright, so that's how you solve question 2 for your Module Excel Set A. Thank you.